Hello, everybody. Welcome back to another episode of Precision Perspectives. It is me, your host, Jordan Yates, marketing engineer at Precision Devices. I don't know why it always trips me up every time I say it. I'm joined today with Victor Lu, who has recently become the Director of Product Line Management for Trimmers, and he's also at Knowles Precision Devices. Victor, say hello to everybody.
Hi everyone. Nice to see all of you. Well, not really see all of you, but hopefully you all see all of me and we'll go from there.
Yeah, it's very interesting entering the mindset of acting like you're talking to a group of people. I just imagine someone's listening, even though it's not live, guys. We're talking directly to you. And Victor, I'm glad you're already addressing the audience.
I know we got to play the audience pretty well, right? Try to get that
Yeah.
engagement going.
Exactly. Well, guys, I'm excited because before Victor was in the world of trimmers, he did a lot of special applications engineering in the world of high reliability and military PRF, MIL standards, all of that jargon that I'm not going to try to explain because he is the expert. So we're going to have him get into it. So, Victor, I'm just going to start us off with our first segment, which is say it plainly. If you
hmm
could kind of in straightforward terms explain to our listeners what is MIL-PRF?
Right. The name itself, MIL-PRF, the PRF calls out for performance. And what that
Hmm.
means is it's a military performance specification. And just to go a little bit more generic, before that we have the military standards. And these are basically the type of standards or the documents that established for, in a way, you could think of it as uniform engineering and technical requirements,
Hmm.
which focuses for obviously military, right, in their procedures, practices, and methods. So going back into the performance specifications, think of military standards as just instruction manuals to tell you or to tell the industry, the suppliers, the companies who are building these devices or components, what you should do to make sure that these components that you're manufacturing or testing are military quality. And
Hmm.
this includes testing methods for, let's say, example, how to test a capacitor, how to test the insulation resistance of capacitor, right? And then when you go into the performance specification, which you would hear 55681, 123, these numbers designate certain specifications under the capacitor world. And within
Hmm.
that, these specifications call out for testing results and requirements that the DLA, which is the Defense Logistics Agency, or the Defense Department wants to ensure that the manufacturing is testing at that quality, at that basically guidance, if you will, to
Hmm.
ensure that these components are within military quality or even space quality at that.
Gotcha. That makes sense when you put it that way. Now, I'm curious, like, why would a capacitor, something so small and tiny on a product that's probably so much more big and like
Mhm.
important seeming, like why do they need to be tested to these standards? Like, why do military customers care? And is it just military that cares? Like, where does this fit in?
That's a very good question. So I that it is very true. A capacitor is really small, right? And it's one out of a whole bunch of components and a whole bunch of hardware that's instated into this whole device or this application. However, if you think about it, if one capacitor is going to cause an issue due to, it cracking, which causes a short or an open, that one capacitor will basically affect the whole application itself. And because of that, all it takes is one for the whole application or the whole component device itself to not to basically malfunction.
Hmm.
And if you think about it, if you put these parts into a satellite or like a military vehicle. If one of those capacitors craps out or in any way, shape, or form causes malfunction, that's dollars and dollars and dollars. And it could actually cause, it'll affect a human potentially,
Hmm.
in terms of military, or it'll affect a satellite, which, oh, I don't even want to know how much money it's used to build a satellite. If that doesn't work at all, that whole satellite may not work or, fact, or function as well as it should be.
That's kind of stressful to think that there's so much emphasis on every little tiny component on a
Mhm.
board. And when I say board, I mean like printed circuit board or however you make your board. And then inside the power stuff, inside something else, and eventually inside the satellite. Like it's kind of crazy that they have made all these standards to where even the manufacturers of tiny parts are adhering.
Mhm.
Is that something that a lot of manufacturers do, or is it more specific to like specialty ones? Like how standard is it to be able to test to these standards? Or sorry, PRF.
Mhm.
I get myself mixed.
No, it's okay. I get it mixed all the time too, but um, it actually took me a year to really fully understand all this. But just to answer your question, like, so there are many different components in this world, right, where it's implemented into a device, such as resistors, capacitors, diodes, you name it. For military specifications, I believe there are distinguished or distinct military performance specifications for each of these components.
Mm-hmm.
For capacitors, specifically MLCCs, we actually have MIL-PRF 55681, MIL-PRF 123. And there are many other military perf specifications for different types of capacitor technologies. So it's not
Mm-hmm.
even different components, but even within the capacitor world, there are different technologies within the capacitor world that have different performance specifications. So you could go
That's
in a
kind of
whole rabbit hole.
crazy.
Yeah, you could go in a whole rabbit hole of all types of components and performance specifications, but that's what standards are for, you know?
I feel like I need to attach a chart of all this to it so somebody can really see like all the different
Oh yeah,
directions we can go.
there are so many directions for
Yeah,
sure.
absolutely. I mean, it's funny because I think I understand this, like you said, but then you realize there's more layers to it, and every time you see another layer, I'm like, why is MIL STD not equal MIL PRF? And it's like all these different acronyms and
Hmm.
standards and performance specifications, and it's a lot to grasp. And that kind of leads me into my next segment, which is who should care? And
Hmm.
I ask that because if someone's listening and they think like, okay, this seems a little overwhelming. Like, should I be someone that knows this? Like, who should be interested in grasping the importance of these MIL, PRF, and high reliability capacitor standards and specifications?
Well, first and foremost, definitely the companies that are building capacitors, they got to make sure that per, they're producing, they're testing, they're fabricating these components the right way. And basically, what
Mm-hmm.
better way to go by the standards of the US government, right? So that's the most important. Then you have all the different market segments and those companies that are under those, such as it's not even military at this point. It's military,
Mm-hmm.
space, aerospace, even medical and plannable. Like
Yeah.
these types of companies, they want to know what these components have gone through. You know what these types of the screening process, how they build the parts, how they test the parts. These customers want to ensure, well, these customers of the capacitor companies, these customers want to ensure that they're getting the best of the best components. And that's why we tie in high reliability, which is basically performance of a component lasting long periods of time while still functioning accurately and correctly, and whatever the case may be.
Mm-hmm.
So,
Would would something that's like MIL PRF tested, would that automatically fall under high reliability, or like what's the overlap there?
so, in a way, high reliability is synonymous
Mm-hmm.
with military PRF specifications because you can't really have a component that's high reliability without screening through these types of military specifications. Although I have to say, you know, in different countries, right, they have the European, the ESCC
Mm-hmm.
specifications. So that's not from the US, but that's also considered high reliability. So in a way, I would say that it's specifications that dictate or at least they list the test items necessary to ensure that these products are going to perform for long periods of time. And that's basically what I consider as the high reliability and military specification alignment.
Gotcha. Okay, yeah, because to me they always seem like when I see one, I see the other. And I know even on our website they have like a lot of overlap. And so
Mhm.
sometimes when I'm trying to understand each kind of technology, I'm like, is it one or the other? Is it both? When is it both? And so I imagine a lot of people that would be listening to this were either they're trying to learn more about the industry and
Hmm.
get an edge by learning about something as niche as this, or they are already familiar and hey, maybe they know more than us. And if you do, guys,
Right.
we're always open to your comments and questions and all of that. And
Hey, Jordan.
um, yeah,
There, I guess you could think of it as, um, what do you call it? Fine dining. And then under
okay,
fine dining would be Michelin,
okay.
because Michelin is like the rated, it could be a specification, but fine dining would be more of a generic um, way of saying this type of cuisine, you know?
So which one's fine dining? Is high rel fine dining?
Fine, yes, correct. High rel would be
Okay.
more of a generic way of explaining what, the quality is, while you go more detailed on what, like, how this food is defined as fine dining. And that goes into, oh, it has certain Michelin stars. Well, that might not have been the best example, but, it kind of gets you to, think about it in that regard. So,
This is actually a cooking podcast. Thank you guys.
yep.
No, I
Yeah,
think
no,
that's a good umbrella example.
yeah.
Okay, so now let's get into some fun parts of critical applications.
Hmm.
Can you kind of discuss with us how capacitors certified to the MIL-PRF specifications play a vital role in ensuring this reliability, particularly in critical military, aerospace, and plannable? Like,
Hmm.
where in the process does this come into discussion? And you kind of alluded to it earlier that like it needs to work, but like, can you just get into it a little deeper?
Yeah, so let's go into the understanding of what's considered a qualified part, right?
Okay.
So the military performance specification, that's basically a document that has all the test items that are needed to be, that the component has to test to in order for it to be considered high reliability or considered within the military specification, right? Um, and within that, parts that are actually qualified and recognized by the DLA, which is the Defense Department,
Hmm.
they are qualified under the QPL, which stands for Qualified Parts List. So within
Okay.
this qualified parts list, it's basically a list maintained by the Defense Department um, in a way to formally evaluate to make sure that parts are compliant to a specification, right? So if you have a
Hmm.
part number that's qualified to QPL, that basically means that whoever's buying this part or ordering this part, they have the confidence that this part has gone through rigorous testing, a lot of screening, and has been recognized by the Defense Department as a product that is that has a quality meant for military, defense, medical implantable, all types of these high reliability applications.
Hmm.
So now if we go further into that, so these parts that are, QPL, once they're QPL, right? Or there are chances where parts don't have to be QPL, where the customer just wants a certain product that goes beyond the specification, right? Those parts are also tested in accordance to the military specifications, but they're not certified or qualified in that regard. So either of
Gotcha.
those components, they'll still be recognized as components that are enough for these types of applications, and the customers who believe that, okay, this part is good enough for our application. It's great for for a Humvee or a radar system
Hmm.
in a military. So yeah.
Yeah. No, that makes sense. So I kind of want to get into like a step by step. We're in the real world. We're doing an application.
Mhm.
I was alluded to once like this analogy of like, or not even analogy, I guess like a process of like scoring like a power supply. So you have to
Mhm.
like meet some sort of score. And if your parts like capacitors are
Mhm.
pre-tested, it helps your score. Do you know what I'm talking about? Is there a way that like you can kind of walk us through like how it helps when they have a like a the score of like reliability, I think it is. Is this something that you're familiar with?
Not really, but I could try to translate it to
Yeah.
the experience that I've had with these components, right? In terms of a score, it goes back into those military specifications, right? Within those
Hmm.
military performance specifications, there are a bunch of these test items that have to be met, um, and each test item has a specific result or It has to be able to withstand this amount of voltage, or it's supposed to not fail or have a QL sample lot of this number, and it has to pass all these test items, right?
Okay.
Once it is able to test all these test items, then in a way it'll be recognized as a quality part, because all it takes is one failure in one of these test items to basically take out the whole component testing itself, or the
Wow.
part won't even be considered high reliability anymore, right? If it fails a certain test item, it wouldn't be able to be considered military grade.
Wow.
So in a way, that's the only way I could try to translate it into a scoring. I mean, for
Yeah.
us at Knowles, we test our parts, right, to all these test items under 55681, 123. They have to pass every single one, or else it's considered a failure, and we have to restart the whole batch, right? So all it takes is one failure of a test item for us to have to go back and start from square one.
That sounds stressful. I feel like I'm
Yeah.
in school taking a test. If it fails, it's like you got to restart the semester. Like it takes a lot to test these parts, doesn't it? Like it's not just
Oh
like a
yeah.
quick thing.
Oh yeah. Like for example, the most important uh, test item that I could think of that I really think is synonymous with high reliability is voltage conditioning. So
Hmm.
for voltage conditioning, this test, it requires the component to be applied twice its rated voltage
Oh, wow.
for at least 100 hours at 125 degrees temperature. And if you think about it, standard operating temperature for these components is -55 to 125. So you're
Hmm.
basically maxing its temperature as well as applying twice its rated voltage. So example, from 50 volts, you have to apply 100 volts at 125 for 100 hours straight. And this is 100% testing. This isn't AQL or sample lot. This is literally every component has to go through this. And because of that, you're able to actually filter out the parts that technically would not have been able to pass. What would we call those? We would call those infant mortalities that you couldn't find in
Okay.
standard testing. Not to say that those parts are bad, or they just won't be military grade. Hmm.
Gotcha. That's kind of crazy though, because like if you're to test that for 100 hours and that's like every part and like all these batches, like I guess it's not like you could just quickly, make these and give them to your customer right away. It sounds like there's a bit of a
Right.
turnaround period through testing. Like, do you know the typical window of like start to finish of making testing and sending out, like without lead times or any of
Hmm.
that kind of stuff, but like the actual physical testing time? Is it usually that 100 hours plus whatever it takes to make it, or is there any more time consuming steps?
Uh, it depends because within performance specifications, there are many different test items, and within
Mm-hmm.
those test items, maybe a customer just wants this group of testing. Maybe this customer wants all of testing, right? So it depends on each individual test item and whether the customer wants these test items or not. But when it comes to standard, or in a way, most of our customers just want what we call Group A testing. And Group
Mm-hmm.
A, there are different types of groups, right? For 55681, there's Group A, Group B, Group C. For 123, oh no, actually, for some reason 55681 only has Group A and Group C. I don't know where Group B went, but 123
It
has
didn't
Group.
pass.
Yeah, it didn't pass its own standards, so we just took that away. But military specification 123 has A, B, and C.
Okay.
Anyways, going back to what I was saying, Group A has, let me see if I could remember, voltage conditioning. It
Okay.
also has, within that, you have cap testing, IR testing, um, DF, which is dissipation factor testing, and then you have solderability testing, right?
Ooh.
So the bulk of that is honestly the 100-hour testing,
Mm-hmm.
So that'll take up, I don't know, I'm sorry, I can't do the math right now, but how many days would that be? Like 100 hours? That's like
Uh,
4, 5?
yeah, that's a little over 4.
A little over 4 or 5, right? And then you add to it the cap testing, the IR, that's within a day. So,
Mm-hmm.
and if you think about the fabrication of the part, it really depends on the industry, right? If you have certain companies that just produce these parts a million a day, they're going to produce these pretty quickly, right?
Yeah.
But for some more specialty factories, such as NovaCap, which is under Knowles, um, there are more, you know, more days are used to be able to make sure that these parts are fabricated for a special requirement or whatever the case may be. So it depends, but if I had to throw out a number for how long it would take for, let's say, a batch of a 0603 capacitor part number two created, I would say about maybe 1.5 weeks.
Okay.
But that's strictly literally if everything goes right and everything's just
Yeah.
on point and there's no issues with all the other departments, right? And even then, that's probably less. But that's obviously you're never gonna have a perfect process. So
Oh, for sure. It'd
yeah.
be fun to watch like a time lapse of that. Like
Oh
just
yeah.
get to see it like and just all the things that goes through. Now, I don't know if you're actually like allowed to show that because I'm sure it's like secret and stuff, but I guess we could go and we could make a time lapse and keep it internal. But I can
Yeah.
imagine it's a cool looking process to see. Um, I have a question. So we've kind of referenced a few times. I'm going to call this our getting into the weeds section as we go a little bit deeper. Um, so these are military standards, but you said that they can be used for other things like medical implantable.
hmm
Why? Like, why is it like that sounds confusing off the bat of okay, it's like that's a different industry completely. Like, is it just like, oh, good enough for military, good enough for us? Like, how does that translate to medical?
Yeah, that's a really good question because, different market segments, they all have their own niche or their own type of standards, but specifically for medical implantable or even aerospace, right? These types of applications, they have their own, FDA and they have their own whatever standards, but it doesn't always pertain to specific components like capacitors, which
Mm-hmm.
is why if it ain't broke, don't fix it, right? And that's why it's
Yeah.
like adopt something that's been working for so long and use that to, this industry. So medical implantable, that industry, there is no capacitor standard. And because of that, they do feel that all the test items within these specifications, those are definitely enough to be able to warrant a capacitor that's medical implantable grade, um, which is more specific to military specification 123
Mm-hmm.
and all the different test items that go in it. And it's not just voltage conditioning, right? For 123, depending on what groups the customer wants, you go into voltage conditioning at 168 hours or more, and then you can go into life testing for sample lot
Mm.
testing, and that could go for 1,000 hours, 2,000 hours, even 4,000 hours,
Oh
depending on
my
what the
goodness.
customer wants. So in a way, the medical implantable companies, they're using the MIL-PRF standards, or sorry, specifications as a reference or as a template. And then if they
Okay.
want to add even more test items or differ or change or tweak a little bit of the test item requirements, they will do so. But they'll definitely use it as reference because it's been established for so long.
How lucky are they to just like get to use those? I mean, shout out to
Oh yeah.
military and defense for making them. Like, I guess it's just kind of one of those things like in military, like it cannot fail. Like it just cannot.
hmm
Like there's just no room for error. And I guess the same basically applies to medical implantable, like cannot fail. And although
Yeah.
there's different versions of lives at stake, either way, it's sort of, affecting human life and the error just can't happen. So I guess that does make sense. I wonder if there would ever become a day where they make their own standards, but with the rate at, you know, those industries move, I doubt it. It seems to be working good enough for them right now. Um,
Yeah, exactly. And if you think about it, these components, they can only be stressed up to a certain point, right? Because you don't want to over test them. Because if you over
yeah.
test them, not only will they all fail, they that you won't be able to get anything out the door. And these test items, they have been established for long periods of time, right? Like I don't even know when the first military specification was created for the capacitor, but ever since that time, over years and years and years, these specifications have been used with success.
Yeah.
So
Yeah, and I mean, it's not like the medical industry is out here just churning and burning. I mean, their development process is long and they
right,
go through a lot of approval. So I don't think they're taking any shortcuts by using that. It seems to be
correct.
the right way to go. But All right, well, I'm gonna switch us over to some fun rapid fire round questions. So, Victor,
Hmm.
can you share either an interesting fact or a fun anecdote related to capacitors in their mill world or just anything capacitor related that you want to share with the audience?
Well, here's an interesting thing going back to what we were talking about. I still don't understand why 55681 doesn't have a group B, which confuses
Yeah.
me. I don't know. If I had to choose something that confuses me to this day, maybe if I like look deeper into it, I'll figure it out.
Hmm.
But there's group A, group C. Fundamentally speaking, A comes before B, B becomes, comes before C. Anyways,
Yeah.
maybe I'm emphasizing that too much, but I always thought that was really strange. So,
Well, if we have some experts out here listening who are a part of the standard setting team, reach out to us. Let us know. Let Victor
mhm.
know. Put him at ease, or you know what? Create a special B for him. So
Yeah, yeah,
we'll take
exactly,
some
just for
wave.
me. Yeah, so it confuses me less, and then the world can keep spinning again, for me at
Absolutely. You know
least.
what? I bet you're not the only one. I bet there's a lot of other people wondering where's the B. There's so many
Hmm.
people that have to be looking at these certifications and standards, and I, I, I bet this is a question a lot of people have, Victor. So thanks for asking.
Oh yeah, no, seriously, like there are times when I always sigh when I have to explain to a customer when I type out group A, group B, or group C, and then I just know in our customer's head they're like, "Wait, why does this specification only has group A and C and this doesn't?" And then I can already like tell like their confusion. And that
Hmm.
kind of makes me kind of just realize, okay, now I have to go through this whole explanation and all this turmoil in my head. I'm like, okay, this could have all been fixed if you added B,
Yeah.
you know?
Or just not had C and made it B. I don't
Yeah,
know, but it seems like a problem that needs to be fixed, and I think it would make a lot of people's lives better. But I'm also
100%.
speaking on something I don't know, so I got to stop making all these bold claims about standards and specifications.
I'm with you honestly. This will save so many lives, so many so many vehicles, so many satellites you don't even know.
So many angry emails of where is the B? Where is
And
the B?
that's where it
Why aren't you doing
starts,
B?
right?
Yeah.
That's where it starts, right? The customer interface.
Oh my
So,
goodness. Well,
yeah.
Victor, this was fun. I feel like I understand it a little bit better, which thank you because I know you've explained all this to me personally multiple
Hmm.
times. So I'm glad that now, anytime I'm curious, I can refer back to this episode. And I think you did a pretty good job of making Mill, STD, PRF, all of the above interesting to listen to. So thank you.
No, I appreciate it. Appreciate your time too, Jordan.
Of course. And Victor, if people want to reach out to you, are they allowed to email you? Are you still interfacing with customers? Or since your promotion, are you a little further out? If they want to learn more about this, who should they reach out to?
My email is always a good start because I'm so
Okay.
used to either answering or at least um, providing that inquiry to whoever it is that's actually able to answer it. So any any inquiry to me is fine, and then I'll just distribute it to whoever is needed.
Perfect. We will put his email in the show notes below. But guys, more importantly, if you know the answer to where B is, let
Hmm.
Victor know. But
Yeah,
if
yeah.
you
B's
need
a
any,
good B's a good letter grade. Just saying, I had a lot of good B's. I'd rather a B than a C.
amen. Amen to that. But you know what?
Right.
C's get degrees, so that's all.
You're not wrong about that either. That's why they kept the C there.
Amen. Amen. Well, Victor, thank you so much. And guys, thank you so much for listening to another episode of Precision Perspectives. I'm your host, Jordan Yates, and I'll see you next week. Bye bye.
All right, thanks, guys.